All right, so in the last video, we created a class called rational that allows us to create rational references pointing to rational objects. And a rational object is quite simple. It just has a numerator and a denominator, and both of which are integers. We also learned about the default constructor. So this is a second constructor, an overloaded constructor, and we chose to have no parameters for that. So it basically sets a default rational as 1 over 1. So the numerator would be 1 and the denominator would be 1. And I can show you that over here. So here is the rational class. Here are the instance variables. And here's the first constructor that accepts two ints. And then here is the default constructor that accepts no parameters, but it just assigns 1 and 1 to numerator and denominator. Okay, and then we ended off by making a pretty important method called reduce. So this reduce method is in the rational class. And what this does is it takes a rational object and it reduces itself, basically. So it reduces itself by dividing its numerator and denominator by the GCF of the two. Okay? Just before we kind of continue on here, if I had some students might wonder why don't we just say reduce like this? Well, this would cause a compile error because it says I don't know where the method reduce is. What the compiler is actually looking in this class, it's looking down here below the main method and it doesn't find a reduce method, so it doesn't work. So what you need to do is put a variable of type rational, because rational, this is the class that includes the reduce method. Okay, the reduce method is inside the rational class, and here it is over here. Okay, so the reduce method, it is public, and it first, so this means that I can call it from a client, from an outside class. So first I'm creating the GCF of the numerator and the denominator, and then I'm dividing the numerator and denominator by that GCF. Okay, and then we've got the GCF code down here. All right, so one way to make this a little bit better, when you're making methods, so we have quite a few methods now in this class, and they are all public, meaning that they are all visible to an outside class, a client. And yeah, definitely this reduce method is it's nice to have public, but the GCF method, this is really just a helper method in order for us to reduce. So there's no real need to make this a public method to outside classes. So we're actually going to lock that in as private, which means we can't call this from an outside class. We're just using it as a helper method in order for us to reduce. So we don't really need the client to know that there's a GCF method in here. This is kind of, it's called data hiding or abstraction, and it's basically making things easier for the clients. We shouldn't even let them know that this exists because they don't need to know. This is just a helper method for our reduce method. Okay, so there is another step up that we can take here. And if I go back to my client, what I'm kind of making it hard on my client by making them have an extra line of code that reduces this rational object. What if we made it easy on the client and we did it for them? So what if we don't make them call this, but we actually put the reduce method in the constructor itself? So at the moment they create a new rational, imagine that we reduced it for them automatically every time, so that they don't have to call the reduce method. And this is a great step to take in this example here. So how would we do that? Well, we're going to leave this because this works perfectly. And we're going to call this method in the constructor. So we're going to go back up to the constructor. And so every time I construct a rational object, I'm going to set the numerator, set the denominator, and then I'm also going to reduce the rational. And notice that I don't put anything here. I can't say R1 because R1 doesn't exist in this class. Remember, I'm in the rational class now, and there is no R1. So there's no need to put a reference because the reduce method is actually in this class. It's down below. All right, so I can call this no problem. Now, do we need to also put it in the other constructor? Not really, because it's already going to be 1 over 1. It's already reduced. So we only need to put that there. Now, what we can do is make the reduce method private also. So now we're making it even easier on the client. We're not even telling them that there's a reduce method. We're just doing it for them. Okay. I suppose there might be an instance where you might want to create a non-reduced rational. That might be a case, but for this example, we'll always reduce the rational number for them. Okay, so now when I compile, and let's go back to here and compile, and what I've done is I've created R4, which is 30 over 40. So numerator of 30, 40 is the denominator, and then I'm printing R4. And so this should automatically print 2/3 without me having to call the reduce method. So let's just check it out, see if it works. Whoops, 3/4. Oh, okay. I'm not sure why I put 2/3. I think I had a different example there before. Sorry, this should be 3/4. So the program is working, and yeah, I must have just changed that from something previously. Okay, good. Now, hold on. Would we put the reduce method anywhere else? Well, notice we have these two mutator methods. We may want to put the reduce method inside here as well. So we're going to call the reduce method anytime somebody sets the numerator, because that might cause the rational not to be reduced anymore. So I'm just making sure that it's reduced. And then I'm also going to call it here in the set den. Okay. All right, so that is a pretty good program right there. It's pretty solid, and it's easy for the client to use. It automatically reduces. So next, what if we wanted to make some kind of functions that we can use on rationals? Like, let's say I want to multiply two rationals together. So if I did this, R1 times R3, okay, will that work? Can I multiply this by this? Well, unfortunately, no. You can't use these arithmetic operators on object types. So we can only multiply primitive types like int, double, things like that. So what we can do, though, to get around this is to make a method. So I'm going to make a method called multiply. And the way that we're going to use this method, the way that we're going to use it, we're going to put this method into the rational class. Okay, so we're going to put it there. And you're going to put a reference on the left. So that's kind of the driver object. This is the one that's calling the method. And then there's another rational object coming in as a parameter. And that's going to be multiplied to this one. You might think, well, couldn't you make a method that looks like this? And this might actually make more sense to you. That looks good. We have a multiply method that takes in two rational objects. But if we do it this way, then you would have to put the multiply method down here. You'd have to put it in this tester class. But I don't want to put this in the tester. I want this to be available in any client that uses rational objects. So we're going to put this in the rational class, and we're going to make it so that one of the objects calls the method and the other object is just coming along for the ride. It's just the parameter that's being passed in. So this is going to multiply R1 by R3. Now, what is this method going to do? Well, I want it to return a new rational object. So I'm going to create another reference called R5, and it's going to be assigned whatever I get back from this. So The multiply method is going to return a new rational, which will be R1 times R3. Okay, hope you're still with me. So let's go and create the multiply method together. And it might make a little more sense after we see it implemented. So I'm going to go over to the rational class. And let's do it, well, maybe I'll do it under GCF. Okay, I like to have toString as my final method. So public, now we're not going to put static. We'll explain the static keyword very shortly in another video. But we need the return type. So this method is going to return not an int, not a double, but a rational. Okay, and the name of the method is multiply, and it takes in another rational object, which you can call R. I'm going to call it other. Okay, so this is just the other rational that we're multiplying by. Okay, so how do I do this? Well, what I want to come up with is a new numerator and a new denominator. So if I go back to my example here, I am multiplying R1 by R3. So it's going to multiply 1/3 by 3/2. Now, just a little bit of math here. Make sure all of us remember how to do this. If I have 1/3 times 3/2, what you do is just multiply the numerators. So 1 times 3 is 3, and multiply the denominators. 3 times 2 is 6, and then reduce it. So our reducing is done. We have that step completed. So all we have to do is this part here. So our new numerator, if I go back to rational, my new numerator is going to be, okay, so this part is a little confusing here. Okay, so this second rational is other. This is the parameter coming into the method. So what is the first one? Well, the first one, notice it's not mentioned in the method anywhere. Like, we don't have a name for it. There's no name for that first rational. So we actually just call it this. So we've seen the this keyword used before. Okay, what does this mean? Well, it refers to the reference that called the method in the first place, this kind of driver object. So the one that calls this method, we refer to it as this. And then the one that's coming in as a parameter, I'm referring to it as other. That's just what I called it in the parameter here. Okay, so how would I calculate the new numerator? Well, I would take this numerator times the other numerator. Okay, and the new denominator would be this denominator times the other denominator. Now I'm pausing for 1 sec. There might be a compile issue. Oh yeah, of course. Missing return statement. So let me come back to this. Yeah, this should be fine. So now what am I going to return? Well, you can do this in two ways. You can create a rational object and make it have new numerator and new denominator, and then I just return R. Okay, so I'm returning this rational object. Or you can actually just bypass this whole reference, and you can simply just return this. Okay, so that actually works. All right, so let's see if it actually worked. So if I go back to my little Jamboard here, if I multiply 1/3 times 3/2, I should get 1/2 as my answer. So it should reduce it for me to 1/2. So let's see what happens. So I'm going to go over here, and here you'll see that I'm creating a new reference that is assigned whatever I get back from this. So now I'm just going to print R5, and let's see if we get 1/2. Rational tester. Okay, there we go. It worked. 1/2. All right, we can try another one. Let's do let's create R6, and that's going to be let's do R3 dot multiply R4. Okay, now be careful. What is R4? Well, it was originally 30 over 40, but it automatically gets reduced to 3/4. So I'm taking R3 times R4. So that's going to be 3 halves times 3/4. So that should give me 9 over 8. So let's compile. Oh, I don't think I printed it. Let's print R6. And it should give me 9/8. If I can find my project window, there we go. Okay, seems to be working okay, 9/8. All right, so I will leave it at that, and of course your task is going to now to create 3 more methods: divide, add, and subtract. So that's going to be your task. Give that a shot, and then you have a nice, fully functioning rational class that could be used in many different applications. Marks programs, anything to do with statistics. So yeah, go ahead and give that a try, and we'll see you in the next video.